Hello viewers, I am Subbalakshmi. In the previous two videos, we had been solving different types of problems based on the de Broglie concept. Let us work out some more in this video also. The given problem is calculate the energy of light of wavelength 450 nanometers. The only data given in the problem is the wavelength of light, that is 450 nanometers, and we are asked to calculate the energy. All of you know the classical equation that E is equal to h into nu. H is the Planck's constant and nu is the frequency. But nu is also equal to c by lambda. Substituting the value of nu in this equation, we arrive at the equation that E is equal to h into c by lambda. So let us use this equation to solve this problem. What is c? It is the velocity of light. This is equal to 3 into 3.00 into 10 raised to the power of 8 meters per second. And the wavelength given in the problem is in nanometers, and we have to convert it into meters. All of you know that 1 nanometer is equal to 10 raised to the power of minus 9 meters. So wavelength lambda becomes 450 into 10 raised to the power of minus 9 meters. And h is the Planck's constant. The numerical value is 6.626 into 10 raised to the power of minus 34. And we are using the unit for the Planck's constant as joules second. Let us substitute in the equation. Then we arrive at 6.626 into 10 raised to the power of minus 34 joules second into the velocity of light divided by lambda. To solve this equation, let us divide it into the numerical part and the exponential part as usual. Taking the numerical part, that is 6.626 into 3 divided by 450. When we simplify, we get 0.044417. And coming to the exponential part, it is 10 raised to the power of minus 34 into 10 raised to the power of 8 divided by 10 raised to the power of minus 9. This minus 9 will become plus 9 when you bring it to the numerator side. So on solving the exponential part, we get minus 34, 10 raised to the power of minus 34 plus 8 plus 9 will give 10 raised to the power of minus 17. And what about the unit side? On the numerator side, there is joule second, joules into second into meters into second raised to the power of minus 1 divided by meters. Cancelling the common terms, it is meters and second raised to the power of minus 1. We arrive at joules only. So the final answer that E is equal to 0.04417 into 10 raised to the power of minus 17 joules, and this can also be written as equal to 4.417 into 10 raised to the power of minus 19 joules. Second problem is, what is the velocity of a moving object of mass 50 grams if its de Broglie wavelength is 2.65 into 10 raised to the power of minus 26 meters? The classical de Broglie equation is lambda is equal to h by mv. When we rearrange it, we get v is equal to h divided by m into lambda. Substituting the values in this equation, we get v is equal to the Planck's constant value. The numerical value is 6.626 into 10 raised to the power of minus 34. We are choosing the unit kilogram meter squared per second divided by the mass m. M as given in the problem is 50 grams. When we convert it into kilograms, this will become 50 divided by 1000, which is also equal to 0.05 kilograms. Then lambda is equal to 2.65 into 10 raised to the power of minus 26. Since it is given in meters already in the problem, we can use it as such. The numerical part of the equation is 6.626 divided by 0.05 into 2.65. When we simplify the denominator, that is 0.05 into 2.65, we get 0.1325, and the numerical part becomes 6.626 divided by 0.1325. The exponential part is 10 raised to the power of minus 34 divided by 10 raised to the power of minus 26. On simplification, this exponential part becomes 10 raised to the power of minus 8. And the units part is kilogram meter squared per second on the numerator side and kilogram into meters, that's on the denominator side. When we cancel the common terms, kilograms and meter, this becomes meters per second. So to conclude, the velocity v is equal to 50.01 into 10 raised to the power of minus 8 meters per second. This is the answer. So in this video, we have worked out different types of problems based on the de Broglie concept. Important things to be remembered are: number 1, selection of the h value. The numerical value of h, the Planck's constant, is equal to 6.626 into 10 raised to the power of minus 34. As you know, it can be expressed either in joules second or in kilogram meter squared per second. The units only differ. Usually, we choose to use the value of h in joules second when the energy factor is involved. Otherwise, we opt for h value with the units kilogram meter squared per second. The second point is the conversion factor. 1 nanometer is equal to 10 raised to the power of minus 9 meters, and 1 Armstrong unit is equal to 10 raised to the power of minus 10 meters. If you remember these values and also these points, you will find it very useful during examination time. So thank you very much for watching this video. Hope you would have found it very useful. Let us meet in the next one.